Episode 10, can you believe it? Episode X.
I know, episode X, the big X.
I know.
I was going to do something sort of special for this landmark achievement, but I couldn't think of anything. So it's just going to be a normal episode, I think.
Oh. I've decided that, you know how people put their scientific handle, the Twitter handle, on presentations or posters, whatever they do, so people like follow them if they're interested. I'm just going to put @generic_drift.
Nice.
You know, I don't want them following my life.
No.
It's what a science output that I'm involved with.
Yeah, it is. It's a real official bona fide podcast now.
Yeah.
10 episodes, you know.
Ooh.
Thanks for bringing the Twitter up as well. I was going to mention now that to all of our listeners, we are now on Twitter and you can follow us @GenericDrift. So do follow us, tweet us. We're sharing, you know, decent science content and also some of the images and stories that we talk about in the show.
Yeah, and more.
And more, of course, exactly. Although obviously all of those stories and images are included in the show notes, accessible via your podcasting app or in the description of YouTube, whatever you use. We're such an accessible podcast.
You sounded like a pilot then.
Did I?
You know, when they speak to you over the intercom, it was very reassuring.
Yeah. Ladies and gentlemen, we are approaching 30,000 feet.
Yeah, I guess that is sort of more your role in the podcast. Don't include this. I was on a date last week, a first date. Mm-hmm. And obviously, at some point, the podcast came up. Like, I'm pretty proud of it. I was going to mention it to him. It wasn't like first 15 minutes, but after you've been talking for a while, you know, it's something to be proud of.
Yeah, definitely.
And he looked at me like dead in the eyes, completely sincere, and said, "So are you the Carl Pilkington then?" Honestly, my jaw dropped. I said, if that isn't because I'm bald, then I'm just walking out of here right now.
You've seen Jurassic Park, haven't you?
Yes, and I've read the book.
Have you? Michael Crichton.
You know what? I might not have seen the original Jurassic Park. I've seen Jurassic World.
Oh. Yeah, I'm talking about Jurassic Park, which I consider to be one of the best films ever made. I truly love it.
Okay.
I mean, okay, so in terms of Jurassic Park, and if you haven't seen the original, I seriously recommend going to see it. Jurassic World is nothing on Jurassic Park. And Jurassic Park is the absolute best. The original's the best one. And then the sequel is not too bad. Lost World, it's all right. It's not amazing, but it's not awful either. Mm-hmm. Number 3, not so much. Not really worth watching that one. And then the recent remakes, or sequels, whatever you call them, they are dreadful. They're just absolute dinosaur shit.
I thought it was okay, but I had a game on the PlayStation 2.
Oh yeah, Genesis.
Operation Genesis, where you like grew your own, did research, grew your own dinosaurs from fossils, and then like built a theme park for them. It was great. It was the best of like The Sims, but then if you like took the fences out and let the dinosaurs get out, they would run around and eat the people, and you would be given a helicopter to go around and shoot them. It was honestly the best game I've ever owned.
I've never played it, but I know it got amazing reviews and people talk about it all the time.
Sorry.
No, it's okay. It's all right. It's fine. But it's interesting you talk about, you know, I guess so you make your own dinosaurs, do you? You build a research facility.
Well, they're based on actual dinosaurs.
Yeah. But you know the premise of how Jurassic Park scientists brought back the dinosaurs, right?
They splice it with DNA from other species.
That's right.
Yeah.
But where did they get the dinosaur DNA from?
Amber. Fossils preserved in amber. Not fossils, just like...
No, I think you can call them fossils.
What, in amber?
Essentially, prehistoric mosquitoes would have drank the blood of the dinosaurs, and then they got trapped in some tree sap or resin, which fossilized, preserving the dinosaur DNA within the mosquito, within the amber.
Yeah.
And then the dinosaurs take that DNA, and then they filled in the gaps.
Dinosaurs?
Oh, sorry, is that what I said?
Yeah. Then
the scientists take that DNA and fill in the gaps with, like you say, DNA from other species. In Jurassic Park, it's frogs. I think West African frogs. And anyway, that allows them to bring dinosaurs back from extinction, which I've always thought is a really, really, really cool premise. And people often laugh at it and make jokes about how unrealistic it is, and it is, obviously. But I do think there is some sophistication there to the science.
Yeah,
you know,
there's something in it.
We reviewed Annihilation, and, you know, we criticised the science in that. And I've heard people have told me that we were overly harsh on that. But I think you can't really do that with Jurassic Park. I like that. That's genetics.
Jurassic Park is a lot more upfront with its science, I would say, though. Certainly in the book.
Oh, really?
But I don't know whether that's just to do with how you can convey pop science, like fantasy pop science, on the screen and on, because if you just show a bank of scientists like doing stuff, it doesn't give you as much information as like a description in a book, maybe.
No, I guess. Yeah. I if you haven't seen the original, you really do need to watch it. It is really a super movie.
Okay.
And the CGI on some of those dinosaurs is honestly, it's groundbreaking. It was groundbreaking when it came out.
When was this made?
It's early 90s.
Okay.
And early to mid 90s. And some of the dinosaurs still look brilliant. A lot of that is because some of them are puppets, animatronic.
Yeah. You see that photo floating around the internet of Steven Spielberg, is it?
Oh, yeah.
Sitting next to a Triceratops, I think.
Yeah.
And animal rights activists kicking off at him killing a Triceratops.
Yeah, you're right.
It's a great shot.
It is a good one. But yeah, that's one of the big puppets, big animatronic dinosaurs, and they're brilliant. It's a really good looking film. It's got a great story, great characters, everything about it is brilliant, and the music, John Williams, is amazing. Everybody knows he is, but anyway.
Yeah.
Anyway, I'm not really going to talk about dinosaurs, having set it up like that, but
okay.
I did want to talk about animals getting fossilised or trapped in amber.
Yeah.
So I didn't know how often this happens. I didn't know whether it was something that Jurassic Park made up or whether it really does happen, but it does.
Yeah, of course it does.
Okay, all right.
It's just tree sap.
Yeah, I know, but I didn't realise that it was quite so preservative, or I didn't realise that it would actually manage to preserve creatures to the extent that Jurassic Park make out.
Yeah, I don't know about blood inside a mosquito.
No, the DNA would degrade over, millions of years or whatever. But nonetheless, like I didn't know exactly how good sort of this amber preservation thing was. But it has happened very recently. Some paleontologists in Myanmar discovered some frogs that have been trapped in amber for 99 million years.
Okay, that's a pretty long time.
That is a really long time.
Yeah.
So that would have been the Cretaceous period, which is the third and last period in the Mesozoic era, which is also known as the Age of Reptiles, when the dinosaurs owned the Earth. Mm-hmm. The other two periods, of course, being the Triassic and the Jurassic.
Yeah.
So do you want to know some cool animals from the Cretaceous? Can you think of any?
Mosquito, frog, dinosaur.
Which dinosaurs? Because lots of the dinosaurs didn't coexist,
Yeah, but I think that... Okay, yeah, I know that. And I think I know that some of the famous ones maybe were around them because they weren't around in the Jurassic, even though they're in Jurassic Park, if that makes sense.
Yes. Jurassic Park...
is a misnomer.
Yes. Jurassic Park used the name Jurassic because it's the coolest word, I think. Better than Cretaceous Park.
Yeah,
You don't think so?
Yeah, Jurassic Park is probably the best one.
Yeah. So I think that's why they chose it. But, okay, some dinosaurs that were around in the Cretaceous. That was Tyrannosaurus Rex.
Yeah, I see, I was going to guess T-Rex, but I didn't dare.
Well, you should.
Brachiosaurus?
Ooh, that's a good question. I'm not sure about that. Let's have a look. Brachiosaurus. I'm just going to look it up. I love Brachiosaurus. Brachiosaurus was my favourite when I was, growing up.
Yeah.
Brachiosaurus is from Jurassic. That was a Jurassic animal.
What about Sinornithosaurus?
Sinornithosaurus. That wasn't bad, was it?
No.
We're not doing that again.
Sorry, I sent Harvey a correct way to say it, and we didn't get it right.
No, it's Sinornithosaurus.
Sinornithosaurus, yeah.
Sinornithosaurus. Instead of Sinornithosaurus, it's Sinornithosaurus. Anyway, that was a Cretaceous. Yeah, you're correct.
Yeah.
You're correct. Some of the other easier ones to say, Velociraptor, which is obviously a very famous one from the films, quite famously a lot smaller than its film counterparts, still pretty cool. Triceratops.
Yeah.
And although they're not dinosaurs, pterosaurs as well.
The good thing about Jurassic Park is, though, it doesn't matter if the dinosaurs were bigger in Jurassic Park because the way they explain it in the film, that's perfectly fine. Like,
yeah, they're tampering with their DNA.
yeah.
Yeah.
Yeah, they're bigger. Yeah, they don't have feathers. Yeah, that's exactly how the dinosaurs want them. I've said it before and I've said it again. No one would go to Jurassic Park in the 90s if the dinosaurs had feathers. And so they made them without feathers.
Yeah. I don't know if they brought back dinosaurs. I don't think everybody would be like, "Oh my God, that's amazing." And then somebody said they've got feathers and they'd be like, "Oh, I don't want to go then."
Yeah, I can see birds here.
Yeah, I guess it's, I don't know. The thing that people like about dinosaurs is that they're like big scary reptiles, right?
Yeah.
Whereas when you look at a bird, it's not like a big scary reptile. It's just, I don't know, a feathery, friendly little thing generally. I mean, they're not, but I think that's the perception people have.
Large flightless birds are pretty terrifying.
Oh yeah. Oh, they're so terrifying, like an ostrich.
But I wouldn't go to Emu Park.
Some people do go to emu and ostrich parks, but it's not as exciting as bringing something back from extinction.
True.
But I don't think all of the dinosaurs did have feathers. I think animals like Triceratops, I don't think that had feathers.
Yeah, probably not.
I don't think anybody thinks that. I think it's more of the archosaurs, the ancestors of birds, who had the feathers. So yeah, I'll just do a few more sort of animals from that era. Like I said, the pterosaurs, not technically dinosaurs, and they actually existed all the way throughout the Mesozoic. And then in the seas, this was the period when modern sharks and rays started to really diversify and occupy niches in the oceans. And then, obviously, living alongside all of these incredible animals in what we now know would have been tropical forest were the frogs.
Yep.
So, considering these fossils are so old, I think it's amazing how well preserved some of the specimens are. They are quite tatty, but they're nearly 100 million years old. So, you know.
Yeah, as would be expected.
Exactly. So, I'm going to send you an image, which will be included in the show notes.
Oh my God.
Cool, isn't it?
Okay, so what I can see looks like multiple things, but is that one frog or...
So I think preserved in the amber as well were little insects as well.
Yeah, well, you can definitely see like a tiny insect next to the frog's...
To the left.
Left foot.
Yeah, and then it was something that looks very much like a beetle or something above it.
At the very top. But then that bit at the bottom, is that an insect or is that part of the frog?
Now, I'm not entirely sure, but I think that what they've done is they've taken that and they've like played around with some of the settings or whatever so that they've got a better image of the skeleton, which I can also send to you. So it's the same image really, but it's just been played with in a similar way to how the astronomers did Pluto, just so that you can emphasize different bits. So you can see the skeleton, and here you can clearly see that frog has eaten a beetle.
Well, was eating a beetle.
Yeah.
It doesn't look like it got very far.
Well, I think it swallowed it.
Oh, you think that's... Okay. Yeah, okay, yeah, I see what you mean, yeah.
Yeah, I think that's inside the frog.
Yeah.
Pretty cool, huh?
Yeah, where's its forelimbs?
So I don't think that all of the body was preserved within... I think, you know, it might have... Some of it has degraded or something. But generally, you know, you can see... I think the most amazing thing is its forelimbs are there. Its hind limbs are missing.
Oh, sorry. I thought it was in completely a different orientation.
Oh, did you?
So that's its head that I can see.
That's its head, yeah.
And it doesn't have any body, basically.
No.
There's a little bit of... I don't know what you'd call that bit at the end.
Yeah, some sort of part of the abdomen or something.
Yeah, and it's got trapped in amber, and 99 million years later.
Actually, I can see what that is on the beetle. Maybe it hasn't eaten this beetle. So that is its leg, and it's... So you can see that the spindly bones are sort of below it. Those are its toes.
Oh, yes, of course, yeah. So you think it's just sitting on a beetle?
Yeah. For 99 million years.
Yeah.
Yeah.
Well, maybe it was trying to eat the one in front of it, because this beetle looks nearly as big as the frog. How big is this frog?
Yeah, but frogs can eat enormous animals compared to their size.
Oh.
A frog can eat something that's like almost the same size as it.
Okay.
So they're just like that, and they swallow it whole, don't they? So it's a new frog species. This is new to science.
Oh,
What?
well, I mean, it's at least 99 million years old, so new is
It's new to science.
newly discovered.
Yeah, exactly. And it's been named Electrorana limoe or something, Limoa. Electrorana limoa. And I always sort of wish I was better at Latin because I don't know what that means. But the rana bit in Electrorana is quite common in the scientific names of frogs. So we have, in this country, in the UK, we've got the common frog, which is Rana temporaria. And I think they're called ranids or something if they're in that sort of family.
Yeah.
But what's really cool about this is that because frogs are so soft-bodied and they live in tropical forest, it's really rare to find fossil specimens. And the record of early amphibians is really sparse, to say the least. So frogs first appeared around 200 million years ago. So this is like halfway through frog evolution.
Yeah.
And that was around the Triassic. And that was when Earth was Pangaea, whereas in the Cretaceous period, it was sea levels, I think, were a lot higher. The land had split off in all sorts of different directions. And it resembles a lot more, the Earth as it is today.
Current configuration.
Exactly. 200 million years ago, they diversified into one of the most amazing groups of animals, in my opinion. I'm a huge fan of frogs.
Yeah, they're okay.
You just think they're okay?
I think they're very interesting. I own a frog.
Yeah, you do own a frog.
And he doesn't provide me with that much entertainment. I guess the life cycle is kind of interesting.
I think the life cycle is incredible. It's so primitive terrestrial. Like those eggs are so delicate and fragile, and it's incredible that they, when you look at a chicken, it lays a really hard egg. There's loads of protection there. When you look at a human, they incubate their eggs within themselves. Whereas frogs are just like, I'm going to lay my egg in essentially like water.
Yeah.
In on the land.
Well, that's what a fish does.
But a fish isn't terrestrial. A fish can use the water from the sea, whereas a frog has had to take that water to the land.
Not all the neurons.
No, that's true. Sorry. Okay. I'm sure I have told you this before, but I used to keep lots of frogs.
Yeah, you have.
Yeah. Mainly tree frogs. But I've also kept toads and dart frogs as well, poison dart frogs. I actually bred a group of fire-bellied toads once and got about 70 offspring up to adulthood, sold them to a pet shop.
Lovely.
Yeah, it was nice. I like the whole life cycle thing. I mean, the fire-bellied toads would lay their eggs in the water, I guess. But the tree frogs, they lay them on a leaf, the underside of a leaf.
Yeah.
And poison dart frogs, in some species, the father will carry a tadpole on its back from one pond all the way up to, like, I don't know, the cup of a bromeliad or something. I think they're fascinating creatures.
Well, it depends on where you are and the humidity of where you are, like how all right you and how long you're all right leaving them out.
Yeah, that's true.
So in a tropical rainforest, you're all right laying it under a leaf, but they won't last very long in Barnstaple.
No, you're right. Desiccation is like a huge issue for amphibians. They need to be moist at all times, don't they? And that's because they're barely terrestrial creatures. They're pretty much aquatic organisms, just living on the land. But some of them are, exclusively aquatic, like your frog, your African clawed frog.
Yeah.
But the majority aren't. The majority are either, a little bit of both or, well, one or the other, I guess. I don't know.
I think a lot are semi-aquatic.
Yeah, I think the majority are semi-aquatic.
Well, they have to be to lay their eggs in water.
Yeah, but of course, being that sort of aquatic, it's pretty difficult to be a frog because they absorb everything through their skin. So with pollutants going up in the world, the frogs really struggle with that. And funguses as well really thrive. There's one, chytridiomycosis, which is knocking out amphibian populations worldwide. Mm-hmm. It's very sad. These amazing animals that have been around for 200 million years.
Yeah. Well, so is the fungus.
Yeah. It's not as cool, though, is it?
Well, I thought that one was cool because you got, like, fruiting bodies on the frogs there.
No, I don't think so. I think you're thinking of cordyceps.
Okay. Is that on ants?
Yeah, it takes ants and grows out all these really weird structures. Now, that is a cool fungus, as long as it stays away from the frogs.
Yeah.
Oh yeah. Anyway, I just wanted to share these pictures because I thought it's really cool. It's really cool to see an animal preserved in the fossil record.
Yeah.
That wouldn't usually be.
I think that's what you said. What is especially cool about it, like I just say, they're especially diverse in humid, temperate regions where you don't get good fossilization, and they're so like small and like fragile. The bones are so fragile anyway that you're just not going to find it in fossil records usually. But this like amber trapping, this Jurassic style amber trapping, has shown us some nice, interesting things about what frogs were doing 99 million years ago, and looks like they were pretty much the same. What would you call your frog-based theme park? Because Jurassic Park's already taken, and this is Jurassic. Did you say?
Yeah, I think they were. I think they were Triassic 200 years ago.
Well, I think they were like Victorian.
Sorry, 200 million years ago was the Triassic. Pangaea Park.
Pangaea Park, nice. So I want to take you to Lake Pátzcuaro.
Have you said that correctly?
I googled it before to try and get a reasonable estimation. Do you want me to spell it for you?
Yeah.
P.
Yeah.
A with an accent that is pointed upright. Yeah. Tzcuaro.
Pátzcuaro.
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 Yeah.
South America? Central America?
Mexico.
Yeah, cool. All right.
Yeah.
Aztec.
So
That's an Aztec name for sure, I think.
Yeah, maybe. Looks a bit Spanish to me. Anyway.
Okay.
I can't tell you that, but it's the third largest lake in Mexico anyway.
Cool.
And it doesn't drain into the sea. And whenever you have a lake like this, you find interesting species there, right? It's cut off from the mainland, so anything that lives 100% in water doesn't make it from lake to lake or lake to river and lake to sea, whatever. So you get an interesting build-up of evolution, basically, yeah?
Yeah.
So among the interesting species in Lake Pátzcuaro is a freshwater amphibian.
Cool.
Called a choke.
Choke?
Achoques.
A choke, okay.
So it looks just like an axolotl.
Okay. They're Mexican as well, aren't they?
Yeah, it's basically I'm not going to say just an axolotl, but, you know, because they're really cool just in themselves. Like, how would you describe them?
An axolotl?
Yeah, so they're like...
It's a salamander that never reaches adulthood.
Yeah.
It always occupies its larval stage. You can, in captivity, I think you can get them to metamorphosize, but when you do, they don't live for very long. But yeah, I think it's neotonic or something, because they're like neonates, basically.
So yeah, because they're still in the neonate stage anyway, like physically, you see them with these like frilly gills.
Yeah.
Gill slits.
Yeah. For living in the water.
Yeah.
And occupying the water 100% of the time, right? Like an axolotl can't come out onto the land.
Yeah, exactly.
Yeah.
So in this lake, this species, very similar to the axolotl, the achoke, can't come out. But it looks very similar. It's still got its gill slits flapping everywhere. We'll include a picture.
Yeah, how do you spell achoke? I want to look at a picture.
ACH.
Yeah.
OCHES.
I can't find it anywhere.
Just Google a picture of an axolotl.
No, hold on.
I'll give you the species name because that's the
okay.
The local common name. But
okay.
Ambystoma dumerali.
This is going to be easy, isn't it?
AMBYSTOMA.
Ambystoma?
Yeah.
That's the same as the tiger salamander.
Okay.
Hold on. So I'm just going to go to tiger salamander. Ambystoma. I can't believe how hard this is. Taxonomy, species. Oh my god, there's so many. Okay, what was it? What was the second one? Was it
Dumerali? Dumerali.
The Lake Pátzcuaro salamander, locally known as a choke.
Yeah.
Yeah. Okay. There's not a picture.
I'll send you a picture.
Okay. Yeah. I'm gonna try and find it now. Hold on. I can't believe there's not a picture on the bloody...
Well, you're going to find it and it looks just like an axolotl.
Oh, yeah.
Or, I'm sure, like a juvenile tiger salamander.
That looks exactly like an axolotl, actually.
Yeah.
Okay, sorry about that whole fiasco.
Well, we can cut some of it out, I'm sure.
No, I'm leaving that all in. All right, no, go on. I'm with you now. A choke.
So these achoques are unique to Lake Pátzcuaro in Mexico, but local people in local culture, they have certain healing properties, and they face like the same threats that amphibians face all over the world in terms of like water quality degradation. So this species is reported to only have around 100 individuals left in the wild.
Oh my goodness.
Yeah, so it's really on the borderline of extinction.
Just like the axolotl.
Just like the axolotl.
There was a time not long ago that that the scientific community announced that axolotls were extinct in the wild, but we have, I think, found since then a little population.
Yeah.
But yeah, okay, go on. Sorry.
Probably because of this, places like conservation charities, places like the Chester Zoo, who did this, doing this project, we're thinking about captive breeding programs and ways that they can restore the population. Yeah. And they went to Mexico to have a look around at the lake and things, and they were told about a local population of nuns called the Sisters of the Monastery of the Dominican Order. Catchy name.
Yeah.
Who use these axolotl type things in these mysterious healing potions.
Oh.
So they use them as an ingredient for a medicine that supposedly cures coughs, asthma, and anemia. Which, I don't know whether it does or not. I don't believe that we've had a scientific test of that. But so, what do you think about that?
Well, it's hard to say, really, isn't it? Because I think people in the West get really annoyed with like traditional Chinese medicine and stuff, and rightly so in a way, because it's right to conserve these species, and generally all of these potions and ointments and hocus pocus, it's all based on tradition and not science, which is something that we tend to really favour science over tradition in the West. But, these, I don't know, it's hard. It's all about educating those people, really. And I don't know if you can really blame the individual quite as much as some people do. It's annoying because how endangered the species is. But really, then you need to educate these people.
Well, you don't.
Oh.
Because it turns out they haven't been fishing these out of the lake.
They've been captive breeding.
They've had their own captive breeding program for over 150 years, and they've got up to 400 achoques just in their monastery.
That is amazing.
So now, I mean, I don't think there's any suggestion that they won't keep breeding them, but obviously they can just breed more, see how they go when they release them, and they've got a captive population right nearby the habitat, not in, Chester, thousands of miles away, that could potentially be put to a good use pretty quickly.
Yeah. No, that is great. That's really cool news.
Yeah.
Yeah, I'm glad I didn't jump on their backs like straight away and be like, no, why are they doing that? Because that's awesome. I've always thought that lots of people get angry about keeping animals in captivity and stuff, and I remember thinking that, like, in the case of like the axolotl, it's really cool that it's a common pet in the UK and all around the world, because you're just spreading like the knowledge of that husbandry for that creature across, all over the place. And if the axolotl does go extinct in the wild, I can't think of many species that are better positioned for reintroduction, because they're represented globally by a captive, a sustainable captive population. But good. Well done to these nuns for doing that. Yeah. How do they prepare these ointments? Does it end in the animal's death?
It doesn't. I didn't read anything about that, but that is what I suspect from what I have read. It just says they use them as part of... So, yeah, I think they probably put them in a blender or something. But the thing about these nuns is, like, the scientists, obviously, who came up with figures like only 100 left in the wild and stuff, have been studying them for a while. But because these nuns have been doing it for so long and passing the techniques and things on from generation to generation of... I guess you wouldn't call them generations in terms of nuns, because whatever, like, nun after nun.
After none, yeah.
They now know the animals like so well that they can differentiate between axolotls and like identify them. Whereas the scientists in the field have to use like radio tags or whatever. Like they've become experts in choke husbandry.
Yeah, and breeding and everything. That is really, really cool.
Yeah, and so I was thinking, like, why aren't we just going through the CITES list or whatever, the IUCN Red list, and saying, okay, you nuns or whatever, you big corporation, you're going to be tasked with looking after this species. And if you don't do it, then if they go extinct, then you're going to get some sort of a penalty.
Or we'll stop funding your church.
Yeah.
Yeah. Yeah, I kind of get that.
Like you won't be able to have free, because, you know, you'd have to pay something about taxes on churches. You don't get your tax exemption. Your order of whatever, nuns, priests, doesn't get the exemption if this species goes extinct.
That is a really, really good way of putting the church to use, actually.
Yeah.
And getting people to engage with the church as like a community as well, because that's something that they're really struggling with, right?
And to get the scientific community to
engage with the churches.
Engage with them as well.
That's brilliant. That's absolutely brilliant. But, you know, also back in the day, all of the best sort of biologists and scientists were all religious people, weren't they?
Well, look at Gregor Mendel.
Yeah. He was a monk, wasn't he?
Mm-hmm.
Yeah. And I've got a book here that was written in the early 20th century, and it's just all on all sorts of different sort of aspects of natural history. It's got illustrations of Megatherium, the giant ground sloth, in there, and also like old fossils and stuff. And it was written by a reverend. Mm-hmm. And it's just some reverend or whatever. I think generally, like, they were the men of science, weren't they, back then?
Yeah.
It's only a recent phenomenon where it split off.
But yeah, they can be put to use now.
But the reason these nuns are doing it is because they believe in, like, the magical properties of this achoke.
I don't think it's magic.
Okay, fine. Like the I don't know, apothecarian properties of the achoke.
Which, you know, I haven't seen anywhere that says whether or not it works. Like, a lot of cures are found in the natural world. Like,
yeah, it's true. And it only, you know, very recently we were talking about how some of those hocusy-pocusy potions are actually very good.
Yeah. Yeah, so I say let them make the potions, but let them get involved with conservation as well, which is exactly what they've done.
I say that too, especially if they're not killing them. I don't know if they are. They might be. They probably are. Although, if it is I think it's neotonic salamander, so when they're in their larval stage, they're able to regenerate their limbs.
Yeah, so, that could possibly be it. They could just be like cutting off a leg and putting that in.
Exactly. All up for that.
Yeah.
Cut off the limbs if it's going to save the species.
Yeah.
And they'll grow back. Yeah. That's probably it.
Yeah. That could be how they get 400, like, at a time.
Yeah. All right.
Interesting.
That is really interesting and a really good idea of uniting the scientific community and the religious community, bringing them together for the greater good and for the conservation of endangered species. Here's a topic we've covered a few times before.
Space.
Yeah, but more specifically, Mars.
Yeah. The red planet.
The red planet. So I feel like the red planet has really entered the zeitgeist since SpaceX has been developing these sort of rockets, you know?
No, I think people have been calling it the red planet for decades.
That's not what I meant. I mean, like, Mars is more relevant now than it's been for...
Oh, sorry. Okay, yeah.
for ages. Like, lots of people... There's lots of news stories about Mars. There's lots of new research coming out. People are really interested in it. So, yeah, and I think it's a fascinating planet. It's a fascinating topic. Our little neighbour red planet. So, why do I want to talk about Mars? So I've got a few reasons. So Mars, I don't know if you know this, but it's currently an object in the late evening sky. So today it's going to come out at about 10:30.
Okay.
So you can actually see it as long as you can see close to the horizon. It's a really incredible red-orange colour at the moment as it sort of steadily approaches what we call opposition. Do you know what opposition is?
I've only heard it in astrological terms.
Well, that's what it is, essentially. It's an astronomical term that astrologers use for, like, oh, Mars is in opposition this week, so you're going to have some good luck or something. Basically, what it means is that the Sun, Earth, and Mars are all lined up in a row, in a straight row, and Mars is on the opposite side of Earth. So that means that from our perspective, Mars rises at sunset and sets at sunrise.
Yeah.
And so at midnight, when you look at Mars, it's perfectly illuminated and like perfectly at the highest point that it'll be in the sky. Does that make sense?
Yeah.
So it's really
accounting for British summertime.
Sorry, maybe not midnight. I'm getting that wrong. I just mean like the halfway between sunrise and sunset.
Okay, yeah. So literally midnight.
Yes, exactly. So opposition is like a really good opportunity to get a good look at Mars, because it's, you know, it's really close, really well illuminated, and you know, we can see it sort of perfectly from Earth. So it's a very exciting time for astronomers. So on the 27th of July, I'd recommend you go outside, have a look, see what you can see. It'll be pretty big, pretty bright. So, and then 4 days after opposition, Mars is going to reach its closest approach to Earth, where it will be just 56.9 million kilometres away, which is 35.4 million miles. Although at those distances, what's a kilometre? What's a mile? You know,
Yeah.
When you get into the millions, who knows? It's just a long way away. But it's close. And the next time it'll be this close is apparently going to be 2035. So it's going to be really close. It's going to be really close to opposition as well. So for those of us with telescopes, there should be some good views of Mars at the end of the month. However, in a cruel twist of fate, Mars is actually currently suffering from a planet-wide dust storm.
Oh, no.
Which is obscuring surface details, which tend to be things like the volcanoes and mountains. Olympus Mons is the most famous, the big craters, as well as the white ice caps, which I have seen before, but very, very faintly. I was really looking forward to seeing some surface details of Mars. Yeah. And these dust storms on Mars tend to last months as well, so it's very unlikely to clear in time for opposition. So a bit disappointing, but it could still be good. Like, you know, if you don't have a telescope, it doesn't matter. And if you do have a scope, give it a go anyway. It's kind of cool, I guess. Like, yeah. we'll witness a climatic event on another planet, and that in itself is quite cool, you know. But I would have liked to see some surface details, really. So that's it. There's the days around the 27th of July. And as I say, I had arranged a little astronomy party back home on the Isle of Wight. I've bought a new telescope.
Yeah.
Like a much bigger one. I sold my old one. She's a beauty, much bigger.
Have you gone for function over fashion this time?
Yes, I have. So it's like a wider one. So I used to have a refractor telescope. I think I might have explained the differences, but that uses glass lenses to concentrate an image, whereas this one's a reflector telescope, and that uses mirrors.
Mirrors, yeah.
Yeah.
I remember you saying, yeah.
Yeah. So this one's sort of wider, but not as long, and it doesn't really look like your typical telescope. It's a bit more complicated as well, but I'm all up for that. Love a good old complex one, you know. I'm into it. So yeah, I'll be taking that down to the Isle of Wight. Hopefully the weather will be nice and we'll be able to see some Mars. Don't know how much I'll see. I'll see if I can take a pic.
Yeah.
Would you like to see an animation of the dust storm taking over Mars?
Yes.
I'll include this in the show notes. So you can see how, this is a very, very close-up image as well, but you can see how it will be obscured.
Okay, yeah, it is quite dramatic.
Mm.
You can still see the ice caps, though.
You can. I mean, this is
the bottom one, at least.
I think that's got to be a deep space telescope. That's not somebody's private telescope at all.
Yeah.
And yeah, actually, to be honest, looking at the animation, I don't know, you can see it. It's just, you know how we talked about the birds of paradise?
Yeah.
And how when you place a bright feather in the context of a dark feather, it looks brighter and more magnificent. You can see that effect in the ice caps too. You can see how when there's more surface details, the ice caps are clearer.
Yeah.
As opposed to when it's dusted over, it's kind of harder to work out where those ice caps are, especially if you're looking through a fairly amateur telescope on the ground. But,
well, it's against the sky, so very black.
Yeah, but Mars is very small. Like from what you see, it's not like seeing Jupiter. Jupiter and Saturn are very, very big objects, and you can see them quite clearly. But
yeah,
Mars is a very small little thing. So if you can make out any detail on it, it's really good. But anyway, I'll include that animation in the show notes. it just sort of shows you sort of what we could have had and what we will have.
Hopefully you can include your own.
Yeah, that would be, I'd love to. I'll see if I can get a picture of Mars and I will put it in the show notes. I'm hoping to get a picture of Jupiter tonight as well, actually. If I do get one, I'll send it to you. Yeah.
Well, follow us at Generic Drift on Twitter to see Harvey's see the planets
exactly.
through Harvey's new telescope.
Exactly. So anyway, not only is this dust storm a bit of a nuisance for astronomers, but it's also causing some chaos for one of NASA's rovers.
Mm-hmm.
So you recall that we discussed Curiosity
in the selfie-taking robot.
Yeah. And I think the episode was Microsoft Sam. And we looked at some of the really cool images, including the selfie that the rover's taken, and talked about some of the science that it's done. But I'm not sure if you're aware of this, but there are several other rovers on the planet as well. So there's actually been 7 in total, and 2 of which were still in operation when the dust storm rolled in. The others, we've sort of lost communication from them. But the 2 that were in operation were Curiosity and Opportunity, and they're both NASA rovers.
Yeah.
So Opportunity, just yesterday, at the time of recording, celebrated its 15-year anniversary since it was launched from Earth, which is an incredible feat because it was only meant to be a 90-day mission initially.
I don't understand how it's lasted all that time.
No, I know. It's incredible, isn't it?
You buy an iPhone, you're lucky if you get 2 or 3 years out of it.
Yeah.
I guess that's the difference, isn't it? Planned obsolescence. NASA aren't making them to just go kaput when the next model's available.
No, exactly. In fact, didn't they recently reveal that they choke like the older versions or something so that the battery slows down? And I think they do that. They throttle it, I think it's called.
Yeah.
I don't think they're doing that with the rovers, though.
Probably not.
But anyway, since arriving on the planet in January 2004, Opportunity is the reason that we've seen evidence for Mars having water for extended periods of time, which are obviously conditions for microbial life on Earth. And also Opportunities explored some of the craters, helping us map the planet, just sort of get a better understanding of Mars. Unlike Curiosity, which is a nuclear-powered rover, Opportunity is solar-powered. So Opportunity has had to enter hibernation, and essentially NASA are just waiting for the skies to clear to see whether the rover will still be operational.
Yeah, because this would be like the best time for it then, had the dust storm have not come in.
What do you mean?
Well, I guess it's behind the Earth, actually, so that's probably not true.
Oh, as in it would get more sun?
Yeah.
Well, it would get sun every day because Mars is spinning round. It just has days, right? It just needs to charge itself up and then head off again.
Yeah.
So I don't think it's necessarily that, but they're obviously with the dust storm obscuring the sun, it's not getting very much light, and so it's as I say, it's entered hibernation. I think NASA are quite worried that it's not going to survive, even though it's well beyond its 90-day mission. It would be a shame to lose Opportunity, who's been such a loyal rover,
Yeah.
So I don't think they're scared. They're worried about Curiosity, with it being sort of nuclear powered. I also don't think Curiosity is in a region of Mars where it's quite so dangerous, like this dust storm. So, I don't know. Scary, eh?
Yeah.
Sending all of our thoughts and prayers to Opportunity.
Can't we go and get Curiosity to check on it? You're saying how small Mars is.
It is small. It's slightly smaller than Earth.
Still pretty big then.
Yeah, but but when you look at, if you were looking at Earth from Mars through my telescope, Earth would be tiny.
Yeah.
The only reason Jupiter and Saturn are so enormous is because they are literally, well, in real life they're enormous. They're huge balls of gas. The red spot, the Great Red Spot, or whatever it's called, on Jupiter, which is a storm. That's the feature, the surface detail. That's 3 times the size of the Earth.
Wow.
Yeah.
The sun looks pretty small.
Yeah.
From where we are.
Yeah.
That's huge.
Yeah, it is pretty big. But yeah. Anyway, if we do lose Opportunity, that will obviously be a tragedy. But roving on Mars will continue through Curiosity, and also, and here we go, here's the news element, a new planned rover.
Yeah.
Okay. Thought you'd be like, oh, yay.
Oh, yay, a new... Okay, yeah.
Yeah.
For Mars, yeah.
And there's something really exciting about this rover, because from my perspective, and from your perspective too, I hope, it's really cool, because it will be designed by UK engineers.
Oh, yeah, that is cool.
Yeah,
I think I did see this, actually.
Did you? It's not going to be the only rover, and I'll explain that in a minute, but this rover, designed by UK engineers, will be a fetch rover. That's what it's called.
It's a good name.
Well, it will have a proper name, like Curiosity or Opportunity.
Surely Fetch Rover is a good name. Like with the dog connotations.
Yeah, I guess.
Like Rover's a dog.
Yeah, you're right. And Fetch for dogs. I think it will have a proper name. The Fetch rover is like the type of rover that it is.
Okay.
So it's like a class of rovers. This is a Fetch rover, whereas Curiosity and Opportunity are science rovers. But I'll explain that. So the purpose of this Fetch rover will be to land on the surface of Mars and retrieve samples of Martian rock and soil, which will then be sent back to Earth for scientific study here on the blue planet.
Yeah.
Yeah, you like that?
Yeah.
So it's an incredibly complicated mission, of which the Fetch rover will only play one part. But here's an essential breakdown of the key components of the mission, okay?
Yeah.
So, in 2020, NASA will send a new, as yet unnamed, rover to Mars, a scientific rover, which will search and drill for materials, storing interesting samples in these pen-sized canisters that will be deposited at various locations on the planet's surface.
Yeah.
6 years after the launch of that previous rover, the recovery mission will be launched. So NASA will land a rocket on the planet, which will eventually be used to get the samples off of Mars, while at the same time the European Space Agency's Fetch rover will be landed, and then this one will head off to locate the canisters and bring them back to the rocket.
Yeah.
So instead of, collecting the samples or analysing the samples, its only role will be to go out and fetch them and bring them back to this rocket. So within 150 days of that, the Fetch rover landing on the planet, the canisters will be launched off into the rocket, which will then rendezvous in an orbit of Mars with a European spacecraft, which will bring all of the samples back to Earth, so that Earth scientists can look at Martian soil, Martian rock, and have a good old look.
Yeah.
What a mission.
What a mission.
The precision that's needed here. Such a network of all these complex elements and engineering projects all working together to achieve something truly unbelievable, grabbing Martian samples.
Yeah. Is this something we haven't done before?
I don't think so. I don't think we've ever...
We've not had Martian rock. I just feel like we have.
I don't think so.
Do we always analyse it in situ?
Yeah, I think we do. That's what the rovers are doing. That's what Curiosity and Opportunity do. Yeah. We're going to have a piece of another planet on our planet.
Yeah. I mean... already sort of do.
Do we?
Well, asteroids and stuff.
Oh, yeah, I know, but this will be like a piece that we've purposefully...
anthropogenically sourced.
Yeah, exactly. And that allows us to be more selective. It means we can find the best bits of rock and, the most diverse samples. Mm-hmm. So one further little detail on this mission, which I think is a lovely touch, and I 100% see why the space agency is doing this. So because this Fetch rover won't have any complex scientific instruments or research elements, it's simply a retrieval vessel.
Yeah.
Once the rocket goes, its mission's complete. It's done. So what it will do then is it will retire to a safe distance where it will film the ascent of the rocket from the surface of Mars.
Yeah, that's a nice little touch.
It's brilliant, isn't it?
So you were going to say it also functions as a Roomba.
Clean
if
up.
There's another dust storm when it comes near. Yeah. It'll just clear a patch so you can have a look at it.
That would be good. That would definitely be good, but sadly not. It's just going to film that and then we'll get to watch that video.
If it's not a dust storm.
What do you mean? Oh, yeah, you're right.
I'll try and film it, but if Mars decides to have a dust storm and all we can see is some nice corally beige dust.
Yeah. And it looks like this one's solar powered as well on the sort of schematics that I've seen. Mm-hmm. Which are in the article linked in the show notes. But hopefully within the next 8 years, we will see this footage and we will have Martian rocks here on Earth.
Awesome.
I thought that was a great little story. And, love all those little robots and rovers that are moving around the red planet. Love that there's more plans for that, and also that the UK is playing a real key role in it. It's brilliant.
You know, if you wanted to, like, maybe we're a bit past it now, but hearing this news, like a kid watching these probes be launched or whatever, could convincingly get into the right field to analyse this data.
That's true, yeah. Yeah, because we'll have that data in hopefully 8 years. Usually these space projects get pushed back a little bit.
Yeah.
But yeah, if you were like if you were like 10 years old, or even sort of 12 years old, maybe even in your mid-teens.
Before you go to university or whatever.
Yeah, go and study. What would you study? Geology?
Well, anything. But, you know, it's interdisciplinary, you know, astrophysics.
Yeah, astronomy, astrobiology.
Increasingly, probably computer science.
Computer science, yeah, definitely.
You know, if you want to be the one programming the robot. But geology, yeah. Astrobiology.
I think geology, for sure.
Yeah.
That would probably be my choice, actually, of those fields. I'm not very good with numbers. Computer science, I just don't think I would enjoy it as much as other people do. It's an ugly way of building things, I think, doing it through code. I'm very envious of people who are really good at doing it, but I just don't think I can create things like that.
Yeah.
You know, I'm very visual. That's why I like doing the branding and stuff for our channel, because I just love all that sort of stuff. But yeah, geology. Get into geology. Get into whatever.
Get into geology, kids, and then in 8 years' time, please do tell us when you've got the Martian rock and invite Harvey round for a look.
We'll still be going.
Oh, definitely.
We'll be on episode, I don't know, 12.
Why are plants green?
This is I see now, like you say, I always think these are trick questions.
It's not.
I think green is the wavelength that allows the plant to absorb the most light so it can photosynthesize better.
Right.
What?
So what do you mean by that, right? You think that green is the wavelength that means that the plants can produce the most light?
I think green...
Photosynthesize the most.
The green bounces... Oh, God, I don't know.
Right. So you were there, right? You were nearly there, yeah?
Okay.
So the green bounces off, the green gets reflected.
And all the other light gets absorbed.
Yeah.
By the chloroplasts.
Chloroplasts, yeah. The chlorophyll in the chloroplasts.
Yeah.
Or more specifically.
Okay.
And so you're not basically using green light for your photosynthesis, even though that's what we so associate with it. It's just what's left over.
Yes, okay.
It's mainly actually red light that's used in photosynthesis.
Okay.
Different proteins use different parts for different processes, but usually it's either red light that's absorbed, or if it's higher frequency blue light, it gets stored and then de-excites to more of a red level, and then it gets used for the photosynthetic chemistry. Yeah?
Okay, yeah.
So this is how it happens in all the plants that we know. Algae, cyanobacteria, like they might have special adaptations so they can get more or less blue light or whatever, but everything absorbs the red light and uses it.
Okay. Is that because the red light is the biggest?
Well, it has the
biggest wave?
Yeah. So that's just to do with the amount of energy it passes on at once, yeah? So red light is of a lower energy than blue light or green light.
Okay.
And that's the area that it needs to do the photosynthetic chemistry.
Okay.
And we thought that this was a universal thing because everything that we've found in nature that photosynthesizes uses chlorophyll A.
Okay.
So we thought that there was literally a lower limit on the light spectrum below which you wouldn't be getting enough energy to produce the chemical reactions of photosynthesis.
Okay.
Obviously, beyond red, there's infrared.
Mm-hmm.
And if you got into that zone, we hadn't found anything that could photosynthesize out of what we call the red limit.
Right, okay.
Which is the visible red part of the spectrum. Down to about 700 nanometers.
Okay, so beyond red,
Yeah.
we have things like infrared,
Micro.
ultraviolet.
That's the opposite end.
That's the other end. Okay, all right. So okay, and until now, we've never found anything that can photosynthesize with infrared. Is that right?
Yeah, well, this can't photosynthesize with infrared. It's called far red.
Oh.
Or near infrared. Sorry.
Okay.
So
far red.
This is something outside of like the visual spectrum, but not far enough outside it to be infrared. So some animals can still like partially
use it to navigate or whatever.
Yeah, but it's not in our visual spectrum. It's about 750 nanometers compared to the 700 nanometers of regular red wavelength light.
So just beyond what we're capable of seeing.
Yeah, but, infrared is only 780.
Oh, okay.
They're all pretty close together.
Hmm.
These are waves we're talking about.
Okay.
So this is the discovery of cyanobacteria in shaded conditions that can grow using this near-infrared light. Mm-hmm. So they actually use a different type of chlorophyll F, as opposed to chlorophyll A. And that can use the far red light with the lower energy and still complete the reactions.
Right, okay.
So this changes completely the chemistry that we thought was behind photosynthesis. It's textbook changing stuff. So much so that it has implications as far wide as things like astrobiology.
Our favourite.
Where scientists had previously thought that at certain planets, because of their angle and distance from a light body, a star or a sun, if they didn't receive the red light, then they couldn't host complex life because they couldn't have photosynthesis. Right,
but now, with this knowledge, we know that they could because they might be able to use this far red frequency.
Yeah, exactly. So there's essentially more planets, extra planets, should we say, where this portion of the light spectrum that we thought couldn't sustain life actually can.
Well, life as we know it, life that uses the sun and light.
All life on Earth, all life that we've ever seen.
Yeah, which I suppose is a good model, I guess.
Yeah. Well, I think if there's anything that this story proves is, as well as we understand anything, there's always something that can throw it upside down.
That's true, yeah.
There's always something that can mean that the biology textbooks have to be written again.
I always hated photosynthesis.
Yeah, me too. The Calvin cycle.
Yeah.
God.
And the, what's the other cycle? The Haber cycle?
That's nitrogen.
Yeah.
Haber process. Krebs.
The Haber process, that's it. I hate all of those sorts of processes. It's so boring. I don't know how to make biology more boring than teaching photosynthesis and the Haber process. It's so dull. I know it's fairly quintessential.
Yeah, even things like, I know what you mean though, because things like the nitrogen cycle and the carbon cycle, which directly involve organisms, different organisms, still so boring, isn't it?
Oh, so boring.
Cycles.
But they're more, honestly, I would say, from somebody with a degree in a biology-based subject, the interesting part of biology is zoology. I think that the photosynthesis and the Haber process and all of that is so much more chemistry than biology, in my opinion.
Well, yeah, it is. Especially as you go to a higher level. The higher the level you get, the more it becomes learning biochemical pathways and stuff. But I could say a lot of things, a lot of the microbiology and things in my degree was biochemical processes. That's the kind of thing that I have done my best to move as far away from as I can.
It's so boring, isn't it?
Oh, yeah, I just can't do it.
And I was terrible at chemistry and maths and physics and all of that. And even some of the most basic biology. When you're doing all the molecular stuff, it's just, I'm not good at it because I'm not interested in it.
Yeah.
I'm interested in it slightly. But give me evolution, ecology, and, natural selection any day of the week over that sort of stuff.
Definitely.
Oh, so much better. And I think that comes across in our podcast. When was the last time we talked microbiology? Just now, actually. Photosynthesis.